So unit conversions, that's using the factor label method, right? You remember that from your handout? Factor label method? All right. So first you've got all your units. You've got your grams for mass, you've got the meter for distance, and then you've got your liter for volume. Right? And then you know they're all in units from those, you have the centigram, which is, when compared to the gram, it's 10 to the negative 2. Micro. Nano. I don't think it's smaller than that. And then of course, when you go up in size, like kilo, here it would be 10 to the 3 meters. So these are all units as compared to the base unit of measure. But if you wanted to say, well, I'll just do a unit conversion and I'll show you, there are negative exponents here, but when you go to them in a problem, it depends on how you compare them on whether you use a negative or positive exponent. So let's say we want to convert 3.5 times 10 to the 8th grams. No, wait, it's nanograms. My brain's still not in here yet. And we want to convert that to milligrams. So using the factor label method, I like it because it's step by step, it breaks it down, and you go back to your base unit first, and then you go to your other unit you're converting to. And if you learn to do the factor label method properly, you cannot get it wrong if you have this memorized. So I start with the 3.5 times 10 to the 8 nanograms. And I go ahead and put it over 1 because I'm going to make this a math problem. And I want to compare, so 1 gram is equal to 10 to the 9th nanograms. So see where I did 1 nanogram is 10 to the negative 9 grams, but 1 gram is 10 to the 9th nanogram. That's why, however we choose to do this conversion, we need to make sure our exponent's correct. And in this case, now we've already canceled out nanograms. Now we can say 1 gram. I like using the base unit as 1. That way it keeps all my exponents positive. Because I start confusing myself once I start throwing positive and negative exponents in there. My overthinking. So now we're converting it to kilograms. So we know 1 gram is equal 1 times 10 cubed milligrams. So that gets rid of your grams, and now you know your answer is going to be in milligrams. So then I like to do one more step in there and do just my numerator and my denominator separate, and then do the simple division after that. It saves trying to do all 3 steps. So 3.5 times 10 to the 8th times 1 times 10 to the 3rd equals 3.5 times 10 to the 11th. And then I divide that 1 times 10 to the 9th. And then simple division, you just subtract your exponents. So 3.5 divided by 1 is 3.5. And then your answer would be 10 to 11. 11 minus 9 is 2. And that's milligrams. So that would be the answer you get, but in the factor label method.
Can I get
So
a picture of that?
Absolutely. So the important thing is, know what your units are, know that what the exponent is for your conversions, and then always go back to that base unit, because 99% of problems I've seen people try to do it in their head, they're like, well, we're changing nanograms to milligrams. So I know nano is 10 to the 9 and milli is 10 to the 3, so they do the math in their head, and 90% of the time they'll do it the wrong direction. So instead of getting 3.5 times 10 to the 11, they would get 3.5 times 10 to the 2. Because they did it the wrong direction, doing it in their head, they subtracted their exponents, and because they thought, well, I can do that in my head. And another thing to remember is we know milligrams are larger than nanograms, so, are they? Yeah. So we should have fewer milligrams, because they're larger. And in this case, I was looking up here and confusing myself. I'm like, wait, that's not larger. But here we have fewer milligrams, because it's just 10 squared. Then we had the nanograms, we started 10 to the 8. Does that make sense? Now, like I said, if you guys can get this factor label method down, it's almost impossible to get them wrong unless you just do what I do most of the time. I have a booger of a time keeping micro and nano correct from each other. Because for some reason, my brain wants to say that micro is smaller than nano. And I know, and I'm getting better at it since I've taught it so much now, I'm forcing it into submission. Nano is the smallest. But, you guys wanna see another example? These are from the handout problems, the Lab 2 handout problems. When we do that one, let's see. Let's do this same direction. So here's one that seems like it would be hard, but it's really easy. Do you care if I just do it right here, because it'll be short. This one is the very next problem. 2.5 times 10 to the 12 milligrams. And we want that in kilograms. No, that's not a really easy one. Because it's gonna go, oh, we're gonna go both directions with that one. So we will have a negative exponent thrown in there, the way I like to use the gram as the base. So in this case, we have 2.5 times 10 to the 12 milligrams over 1 times 1 gram equals 1 times 10 cubed milligrams. 1 gram at the bottom is equal, 1 gram is equal 10 to the minus 3 kilograms, because a kilogram is larger. So in this case, so it's 10 to the minus 3 kilograms. I gotta make that a 3. So in this case, you could have done it either way, but you gotta stay consistent, and you still would have had a minus and a positive. So we could have said a milligram, that 1 times 10 to the minus 3 milligrams, 1 times 10 to the minus 3 grams is equal to a milligram here. But then you would have had this switched the other direction too, and this would have been a positive exponent. So either way, you're gonna have a positive and a negative in this case, no matter which way you decide to do it. Because I like always using the base unit as the 1. And that way I feel like I'm always going back to that. That's my rock. It's like where I'm going to as a base. I'm gonna go ahead and write it the other way that you could do it. So it would be times, so it would be 1 milligram is equal 1 times 10 to the minus 3 grams. This would be 1 kilogram, draw out right here, is equal 1 times 10 cubed grams. See how I just did the other direction there? So I just, the milligram was 1 and the kilogram was 1, and I gave the unit in grams. And like I said, I think it's more consistent doing it this way, going back to that base unit and making it the 1. So now just to break this down and do the math for it, the numerator would be 2.5 times 10, 12 minus 3 gives you 9. And the denominator would be 1 times 10 cubed. So 9 minus 3 would be 6. So it'd be kilograms. And see, so the kilogram is much larger, so there's a smaller exponent. You got it? I guess I'm gonna have to erase now, so get pictures if you want them, I'll get out of the way. I'll try to write bigger and take up more room, but then I can't leave everything on the board too, that's